Okay, I actually just realized I forgot to greet you guys. How are you guys doing? Ish. Hmm? Hi. Did you have class before? What were you guys doing? Regular? Oh, legal interpretation. Okay, I see. I see. Okay. I see. Was that with Bruce? Oh, okay. I see. Right. So, as usual, we're going to do some exercises. I think you guys will be quite pleasantly surprised by the exercises that we're going to do, because I think you'll begin to realize that actually this learning unit is rather decent. It's not that bad. So I want us to go to, for homework, guys, I want you to go and do exercise, revision exercise 3, and then revision exercise 5. Revision exercise 3 and revision exercise 5. Right. So here, we're going to start with revision exercise 1. And here, under question 1, it says, let the random variable x represent the number of bicycles sold per day, okay, by Jones Bicycle Shop. The probability distribution for this activity is shown by, answer the following 4 questions. Okay, so there we've got our probability distribution, all right, for when x is equals to 0. In other words, we haven't sold anything. When we've sold 1 bicycle, when we've sold 2, we don't have the answer to the probability when x is 3, when we've sold 3 bicycles, and then also when we have sold 4 bicycles, the probability of that is 0.1. Cool. If the above table covers all possible outcomes, find the probability that the shop sells 3 bicycles in a given day. They're saying find the probability that we sell 3 bicycles in a given day. Okay. No, here we don't need to use the Z table. Because think about it. They're saying, where did they say it? Man. Above table covers all possible outcomes. So we know all possible outcomes equals what? 1. Isn't? All possible probable outcomes is going to be equals to 1. So for us to find 3, we basically need to say, okay, what is the probability of 4, probability of 2, probability of 1, probability of 0? Okay, if all of these is equals to 1, then that means that the probability of 3 is going to be equals to 1 minus the probability of 1. Let me just do this, maybe this will be easier. Probability of 1 isn't, plus probability of 2 plus the probability of 4. That will give you then the probability of 1, isn't? Is it making sense? And they've given us this. So now it's just about inserting the values. So here probability of 1 is and then plus also the probability of 0. We forgot to add that one. Because that is also a possibility, isn't it? That is a possible outcome. So probability of 0. Okay, so let's see what's happening there. So 0.2 plus 0.1 plus 0.3, and here's 0.1. Yep. What do we get? Minus 1. What do we get? What are you getting? 0.7. Is that what you guys are getting? 0.7. 1 minus 0? Oh, this is 0.7. Okay, yeah, no, I'm with you. Now I'm with you. So we're saying then 1 minus 0.7, which is obviously going to give us 0.3. Okay, so the probability of selling 3 bicycles is then your 0.3. Happy with that? Okay, let me just make sure. Okay, we are. Okay, so that's your first one. Then we go to the next one. Here they're saying find the probability that the shop sells 1 or 2 bicycles on a given day. Okay, so they're saying the probability that we either sell 1 or 2 bicycles. So basically we are saying the probability of x equaling 1 plus the probability of x equaling what? 2. Okay? Either one of these. All right, so we have to combine them, isn't it? So what is the probability of getting x as 1? Or in other words, selling 1 bicycle. What's the probability of selling 1 bicycle? 0.1. Okay, and then the probability of selling 2? 0.3. Okay, which then means this is equals to 0.4. We have a 40% chance of either selling 1 or 2 bicycles. Makes sense? Okay, right. Then we go to the third one. It says, what is the probability that the shop sells at least 1 bicycle in a given day? And this is where they start to trip us up a little bit. That language of at least, more than, less than, okay, is where things get a little bit tricky, because we now have to interpret what are they saying. So they're saying, what is the probability that we sell at least 1 bicycle? Okay, how are you getting it? Uh-huh. Okay. You said you got 0.5. 0.2. And then what else did you do? You left it like that? Okay. So then let's just come do it together. I think you're definitely on the right track. Let's just see. So if we say we want to sell at least 1, what does it look like? What is x? X, we're saying probability of x being what? 1 or greater than 1, isn't it? So we're basically saying we want x to be any of these except for 0. Can you see that? So this is pretty much the same as saying, remember complementary probabilities? So we could say the probability, the probability of 1 minus the probability of x equaling 0. Okay, this is what we are basically looking for. Let me do it like that. Does that make sense? So I think it's a quicker or easier way of doing the calculation, but this is not the only way. So if in your mind there's a different way, by all means, more than welcome to try that approach. So here we're then saying, what is the probability of 0? They've given it to us, which is 0.2. So 0.2 minus 1 is then going to give you 0.8. So the probability of x being equal to 1 or more, because they said at least. Okay, so we're happy if it's 2, we're happy if it's 3, we're happy if it's 4, is then obviously 0.8. So this is why I was asking you, what did you do? You see, okay, but you are on the right track. Okay, so that then is your first section there, right? Now let's see. We'll see if I'll be able to, I think, just in case somebody wants to look at this later. Oh, sorry, that's not what I wanted to do. Let me just move this. Right, okay, so going to now question 2, all right, so that we're near our question, so we can refer. Let's see. A Cape Town courier service promises 80% of Johannesburg-bound parcel deliveries will reach their destination within 12 hours. What is the probability that 7 parcels sent at random times by a particular client in Cape Town, 1, only 1 is delivered late, and 2, only 1 is not delivered late? Okay, what now must happen? And this is where now we need to establish what type of question is this? What type of question is this? What can we use to try and answer this question? Do you remember when we did yesterday's theoretical overview of learning unit 6? We touched on some discrete probability distribution methods, isn't it? What were they? discrete probability distribution methods. We had let's go back there. Oh, I actually closed. It's fine. Close my slides. Okay, this is what I want. Yes, there's the Poisson. Then we also have the first one that we introduced was the binomial, 100%. Okay, so where's that thing now? Binomial. Binomial, there we go. Okay, and here we see the formula. Okay, so what do I want to do? I want to screenshot this. This is what I want. Okay, now we have to make sense of this thing. Okay, where do I want to paste this? Let's paste it up here next to question 1. Okay, let's see. Right, I'm going to make it smaller just now, but in the meantime, right. It looks like I won't be able to do that. So here, the binomial question. What is the probability that X successes will occur in a randomly drawn sample of n objects? Okay, so here we're saying what is the probability that of the 7, can you see we've got a number of objects, 7 of the 7, only one will be delivered late. Here what did they say? That X successes will occur in a randomly drawn sample. Can you see the sample is the 7 deliveries? Okay, X successes is the success would in this case be delivering late. Okay, so this is definitely a binomial question. Okay, and it's important for you to immediately identify so we don't waste time thinking, how do I answer this question? Because if we know how to identify that this is a binomial, right, then immediately we know, you just look for the formula for a binomial. Does that make sense? And then the only other thing that we need to know is which values, where do we insert the relevant values for a binomial? Okay, that's you guys' job. You need to know how to identify what formula to use, in other words, what method, statistical method or mathematical method, then how to apply that. Okay, so you do have to have some level of understanding, and we only get that through practicing of questions. Okay, anyway, let me just make that a bit smaller. So now we're asking ourselves, okay, cool, we now know this is what we need to use. Okay, just want to make that smaller so we can take advantage of the space below. Okay, fine. Okay, right. So here now, n is the number of, or the sample size, the number of independent trials. Okay, x is the number of success outcomes. So here, the success outcome would be only one delivered late, one delivery was late. Okay, then here, P is the probability of success outcome on the single independent objective or the single independent trial. Okay, then 1 minus P is obviously the failure outcome in the single independent trial or objective. So here now we say, okay, cool. So our formula, you can see, is this one here. Probability X is equals to n x p x to the power x 1 minus p n minus x. So let's substitute. That's all we need to do. We want the probability that this delivery is late. But we know that n is equals to 7 because there's 7 independent trials or 7 objects, right? Then C is your combination. X we're saying is 1, right? We only have 1. We want only 1 late delivery, isn't it? Okay. Then we're saying times. So I'm just going to put a dot. I think it'll be easier. Otherwise, we might mix this X with the times. So now the probability of us being late is what? Here they only gave us, they said 80. A Cape Town courier service promises that 80% of Johannesburg bound parcel deliveries will reach their destination within 12 hours. Okay. So that's the promise of what? Them being delivered within 12 hours. So in other words, on time, isn't it? So what's the probability of it being delivered late? 20%. How are you getting the 20%? You are basically saying 1 minus 80%, isn't? Which is giving you that 20% that it will not be on time. Because this is if they deliver on time, isn't? So the opposite, or there's only, this is the good part about binomial. It's either or. Either we are successful or we're not. Either we deliver in 12 hours or we don't. Does that make sense? So here, there's no room for any other outcomes. Either we have delivered on time or we haven't. And we know that the 80% is us delivering on time. Are you with me there? Are you sure? Ask my sister. Why is the 1 needed? Oh, remember in probability we say the total probability of all possible outcomes is equals to 1. You can do that because we know that when it comes to probabilities, either you say it's out of a percentage, so we can say out of 100%, or we use 1. So we can do it that way. So if you're not using the percentage, you say 1 minus 0.8. Yes. Yes, so I was obviously just taking for granted saying you guys know that obviously we're then saying 80% is the 0.8 is a fraction. Okay. We're together now. Okay. She's smiling now. I'm comfortable. I'm comfortable. Okay. So now we know our probability. So it's 0.20. Okay. Or you can put 20%, but it's easier this way when we start drawing. The success outcome is come. Why is it 20? No. What is the remember, the success outcome is determined by the nature of the question. So if we go back to the question, it says only 1 is delivered late. They want the probability of if 1 is delivered late. So it will be a success if we can establish if 1 is delivered late. Can you see that? And I'm just going to say this now since we're on the topic, because you're asking a very relevant question. When we go to the second one, it says only 1 is not delivered late. So basically they're asking if the probability if only 1 is delivered on time. Can you see the success? What? It changes depending on the question. Okay, so thank you for asking that. So X here is 1, all right? All right, then here we're saying 1 minus P, which is 0.20, okay, which will obviously then give us 80, but we'll get there. Then N we know is 7 minus 1, okay. So I'm just going to erase this at the bottom here because I want us to, or maybe let me not erase, because you never know, maybe someone might ask a question and then might need to reference back. Yeah, we'll see how long I can do that for. Anyway, so here we go. Where's my calculator? So you have to punch this 7C and then, 7 and then shift. You should get your NCR on your calculator. And I'm praying that you guys have this thing on your calculator. So, do you have it on your calculator? That's the first identifier. Make sure you have it. This NCR. This is what I'm talking about. I'm sure there's an app. You saw it?
Oh, the one
Yeah,
by
that's
the
the one.
divider.
Yes, that's the one. Okay. Found it. Okay. So let's punch it. Okay. Can you sit next to her just so that you guys can at least do it together? So that at least when she gets home, it's not all starting all over from scratch. So you punch this in. So what I've done, and this is my method, you guys don't have to do it like I do it. I then go 7, second function, and then 1. I've calculated that. I'm getting 7. What are you getting? You're getting 7? Yes.
Are we calculating this one by one?
So
or the whole thing at the same time?
I calculate it section by section. I calculate this bit first. After I calculate this bit first, I store it into my calculator. Store in A. All right. Otherwise, you're going to need to write it down somewhere. Does that make sense? Once I've done that, I then calculate the next section. So 0.20 or 0.2 to the power 1. Store that in B. Okay, we've now calculated this part. Then I say, okay, 1 minus 0.20, which is obviously going to give me 0.80 or 0.8. Then I say to the power 6, because 7 minus 1 is 6. And I store that in C. Okay, now all of these, you are timesing all of these. Let me put another dot there. Okay, so I just go recall A times recall B times recall C. And I do the equal sign, and I'm getting 0.367002. Yes.
The 1 minus 0.2.
This one here is, I got 0.262144.
So 0.26?
0.262144.
You said 7 times 0.2.
I'm lost. Where are you now?
Did you times 7 times 0.2?
Yes. 100%. I times each of those 3. Okay, are you getting the same thing? Okay, so you'll see, if you look at your answers, you'll see that there might just be a rounding difference. Okay, right. But otherwise, we are definitely on track. Supposed to? You can. I think in the test, we should just check when you do practice tests to see. They should write on the top of the paper. I know they usually do this for finance or accounting. Say if they want it to 2 decimal place or 3 decimal place, whatever the case may be. So we can start to get a feel for how many decimals they want. But I've seen here, working to 6 decimal places works best for me to get what they have got. And then it's just about rounding it off. So I would advise that you work with that. At the very least, at least 5. Okay, that's what I would advise. But yeah, then we go to the next one. Now they're saying, what is the probability of only one is not delivered late? So we are then saying here, the probability of X, and maybe let me just use a different color here. The probability of X is equals to, and we're still using the same formula, isn't it? So I'm not going to rewrite the formula. Still have 7 objects, all right, or potential outcomes or observations, okay? C, X is still 1, okay? But now P is going to change because the success probability is now 0.8, okay? It's now about the deliveries being on time, okay? To the power 1, because it said only 1 is not delivered on time. Also, only 1 is delivered on time. The thing, if the English is a problem, yeah, it's going to be tough. So then we say 1 minus 0.80 this time to the power 1, sorry, not 1, 7 minus 1. Okay. And now you'll see that if you have managed to plug in the right variables into the right formula, you're home and dry. Okay. Here you're going to get what again? Should be 1, it should be 7, right? Here. Okay. Then times what? What did you guys get? What did you guys get? No, just here. I'm still just here. 0.80 to the power 1 is 0.80. Okay. And then here we're saying times 1 minus this is going to be 0.20. And then to the power 6. What do you guys get here? Oh, you calculated the whole thing. Okay, no, it's fine. Tell me, I'm not calculating. I'm trusting you guys now. So, what did you get? So we can compare with others. 3, 5, 8, 8, and Grammarly, you must chill. 8, 4. What did I get over here? Are you guys getting the same thing?
Yes, sir.
Yeah. Okay, so it's not that bad, ne? You think? Okay, it's fine. So let's move on. You guys will let me know if there are any questions. Okay, so now they're telling us, privacy is a concern, all right, for many users of the internet, all right, definitely. One survey showed that 71% of internet users are concerned. The moment you see them mentioning percentages or certain numbers, you know, I need to underline, I need to make sure I take note of those things, okay? Are concerned about the confidentiality of their email. Based on this information, what is the probability that a random sample of 12 internet users, okay, they're basically telling us our sample, the number of objects, okay, 4 are concerned about the privacy of their emails. So again, we want to use the binomial because again, what are we assessing? Either you are concerned about your emails regarding privacy or you are not, isn't? And they've given us a sample. So here, let's quickly calculate. Okay, now I'm going to just erase, guys. I've tried my best. I have tried. Alrighty, okay. So what color was I using? Yes. So here we're now saying the number of observations is 12, combination, but we're looking for 4, okay? And the success would be what? What's the probability of success? 71. Yes, it's 71 because we are actually talking to people being concerned about their privacy. And they told us a survey shows 71% of internet users are concerned about confidentiality. All right, so 71, okay, to the power, what? 4. And then 1 minus 0.71, 7 minus 4. Ah, sorry, 12. This should be 12. Should be 12 because we got 12 observations. So what do we get there? What are we getting there? 0.00062924. It's quite long. Are you getting the second zero here? Is it? Okay. Is everybody getting the same thing? Still working on it. So when I see you on Thursday, I'll tell you guys how we're going to go about revision for test 2. But those are the papers we're going to look at. And the exam. We're going to look at your 2022 exam for BSTA6212. Because that's the only exam that I saw that has your actual module code. So what we're going to do is we'll just look at the exam, but we'll pick out the topics in that exam that are for learning for test 2. So that way we're still focused on the type of questions that they can ask us for test 2. Yeah. It's it's correct. You're getting the same thing. Okay, that's great. It's a little bit unfortunate that, yeah, I think 2023 they didn't upload the past exams for this. They would have helped to give us some sort of guidance also, but it's okay. I think that will be suffice in terms of getting us ready. And then obviously you guys just need to make sure you do the questions in the workbook. I actually saw in the exam some very similar questions to questions we've already gone through and from the workbook. So I think if you're good on your workbook, you're good on those past exam papers and tests, I think you'll be okay. You will definitely get through test 2. And remember, there's a burger on the line. Just saying. Aye. Not test 1, guys. Not test 1. You guys would bankrupt me, eh? So here, number 4. Here they're saying, according to an article appearing in a Sunday newspaper, 70% of all South African households have a cell phone. Okay? Suppose you are conducting a survey on customer satisfaction regarding cellular phones. Okay? If you called 7 households selected at random, calculate the following probabilities. 7 households. So that's our sample size. Okay. So number one, the probability more than 0 households have a cellular phone. Okay. Right. So what now must happen here? We are saying basically, takes us back to this other thing that we did. Just, where is it now? Isn't here they said the probability that more than 0 households have a cellular phone. So it goes back to saying the probability that we have 1, the probability that we have 2, probability that we have 3, 4, 5, 6, and even 7. Isn't? So we basically want a probability that we do not have 0 households. Isn't? More than 0. So we can say probability that X is equals to, sorry, not equals to, is greater than 0. Okay, which is equals to 1 minus this probability of X being equals to 0. We want, because basically we're saying we want any other outcome other than X is equals to 0. What is the probability of those events? Okay, so then easiest way is to calculate probability of 0, then just minus it from 1 to get that. So probability of X equaling 0, how do we get that? More than 0. Okay, so we go back to our formula here, isn't? So here we're then saying probability of X is equals to, how many observations do we have? 7. C, and then X is going to be what? It's going to be 0. Okay. And then we say times the probability of what? What's the success outcome? Yes, 70. Because we actually want them to have cell phones, isn't it? And X is still 0. Then we're saying times 1 minus 0.70. And then here N we said is 7 minus X or 0. Thank you. I think my brain froze there for a second. Guys, we'll take a break as soon as we are done with this first one. What do we get? See, it's nice now, huh? You just throw these things into your calculator and you got your probability. Because you understand the formula. 0.0002187. Okay, now we have that, but we don't have our final answer. Because remember earlier we said it's 1 minus the probability of X equaling 0, which is what we are calculating now. All right, so we then have to say 1 minus 0.0002187, which is 0. Yes, it's a 9997813, and that is your final answer. So there's quite a high probability that households have more than, sorry, that we have more than 0 households with cell phones. Okay, we have like a 99.9% chance that the 7 households that we obviously go and investigate, that there is at least more than 0 cell phones. Okay, right. So let's take a break, and then at 5 past we'll continue, and we'll probably finish this off, and then do activity revision exercise 2 as well. Yes.